Okay, so the next thing that we have here is the median of group data, and basically to calculate the median of group data, let's see first the median of group data. Okay, so basically you remember from the previous videos that the median is the measure of central tendency, which gives the value of the middlemost observation in the data. So it's the measure of central tendency that gives the value of the middlemost observation in the data, of the middlemost observation in the data. So what that means is that suppose that you have, for example, of course, provided that your observations have been arranged or sorted in either ascending or descending order, right? So what that means is that, for example, let's say you have 1, 2, 3, 5, 6, 8, and 9. Now these observations have already been arranged in ascending order. So the middlemost data here is basically you have 1, 2, 3, 4, 5, 6, 7 observations. So the fourth observation here is the middlemost data, and that is your this observation is your median. On the other hand, so in order to get some sort of formula for this, if I call this, for example, the first observation, the second, the third, and all the way up to the nth observation, if this is the nth observation, then this observation that falls between all of the observations can be given by 7 divided by 2 plus 1, or 7 plus 1 divided by 2. So that's n plus 1 divided by 2th observation, right? So that's n plus 1 divided by 2th observation. And on the other hand, if you have, for example, these observations, like for example 1, 2, 3, 5, 6, 7, 9, 11, for example, and you have 2, 4, 6, and 8 observations here. So here you basically what you saw was that basically the number of observations was basically 7, which is an odd number. Over here the number of observations is 8, which is an even number. So when you have an even number, then you can pick, for example, you can pick basically these two observations that fall exactly between these numbers. And since now I have two numbers over here, I have to calculate 5 plus 6 divided by 2, find the mean of these two observations, which is equal to basically 5.5. And this will be the median of this data. So in cases where in cases where basically you have the number of the observations is even, you will get two numbers, and then you will have to calculate the average of those two numbers. The average will be the median of your data. And so this term over here can be given by n divided by 2th term, and this term over here can be given by n divided by 2 plus 1th term, or plus 1th observation. So you find the n divided by 2th observation and n divided by 2 plus 1th observation. Take the average of these two observations, and that will give you the value of the median of the data. So that's basically all in case of ungrouped data, and that is basically the concept of median, meaning that even if your data is basically group data, then of course even in that case, when you find some number as the median of your observations, that's basically what that number is basically. That is basically what that number actually means or represents. Now, suppose that we need to find the median of this data here, and the data is basically the marks of 100 students. The marks of 100 students, these are the marks obtained out of 50, and these are the number of students, So you have, for example, 20, 29, you have 28, you have 33, you have 42, you have 38, you have 43, and you have 25. Okay, so, and then you have basically the frequency is 6, the frequencies are 6, 28, 24, 15, 2, 4, 1, and 20. So that's basically the data that I have. Now I want to find the median. I want to find the median of these marks. So of course, as you can see, that your data has not been arranged in either ascending or descending order. So then what you need to do is that you need to basically arrange your data in either ascending or descending order, and then basically create some sort of frequency table for your data. So these are your marks. These are your marks. And these are the number of students. The number of students. And so I can write, for example, 20, frequency 6. Then I have 25, which is 20. The frequency is 20. And then I have 29, which is 28. 29, 28. I'm sorry, 28. I already had 28 here. I already had 28 here, so 28, 24. 29, 28. 29, 28. Then you have 43, 38. So you have 33, 38. 33, 38, 42, and 43. And 33 is 15. 38 is 4. 42 is 2. And 43 is 1. Okay, so that is the table that we now have. Now if you want to calculate basically now you know that the number of these marks, if you add all of these together, you should get 100, meaning that this is 44, 50, and you have 50 there, and you have 28, and this is 3 plus 4 is equal to 722, so it gets 0, 1, and then 100 basically. So this, if I call this, for example, f of I, you know that your sigma f of I is equal to 100. So now, since and you can call this n as well, or capital N, they call it capital N, meaning the number of your observations, or basically sigma f of I. They call it basically capital N. Now, since n is an even number, we said that we had to find n divided by 2th observation and n divided by 2 plus 1th observation. So n divided by 2th observation would be 100 divided by 2, which is equal to 50th observation and the 51st observation. And the 51st observation. 51st observation. So then you need to write the cumulative frequency of these observations, which they call it CF basically, because otherwise I would have to just keep counting. For example, 6 plus 20 is, for example, 26. 26 plus 24 is equal to, for example, this is 0, and then that's 50. So the 50th observation would be no, not the 50th observation, but you see, if you go all the way up to the end of these observations, that would be 50, and then the 51st observation would fall within this category, so you would get a 28 and 29, right? Because you have 26 plus 24, which is equal to 50, meaning that the last observation here would be the 50th observation, which is what I'm looking for. So that's a 28. That's a 28. And then the 51st observation would be basically a 29. So then what I need to do is just simply add these two together, 28 plus 29 divided by 2, which gives me a 28 plus 29 is equal to 17, 1, that's 57. 57 divided by 2 gives me 25, 28.5. 28.5. So now that's one informal way that you can find this. Okay, that's one informal way that we can find this. But if you want to find it in a better way, meaning that you saw that over here I had to do a couple of calculations to get to the 50th observation and to the 51st observation, and then I had to manually basically calculate everything. So then what I'm going to do is that I'm going to take note of these 50th observation and the 51st observation, and then basically erase all of this. And then what you can do is that calculate the cumulative frequency of all of these frequencies, which you can call cumulative frequency, CF. Now what that is very simple. It's basically the same thing that I did over here in order to get to those observations. For example, I write basically over here, I start with a 6, and then 6 plus 20 is 26. 26 plus 24 is equal to 50. 50 plus 28 is 78, and 78 plus 15 is equal to 80, 93, and then 93 plus 4 is equal to 93 plus 4 is 97, 97, 99, and 100. So that's basically the same thing that we did, but in a more organized way. And so now let me go based on the text. Let me see what they have done here, because what I do might be sometimes, I mean, it's better to basically okay, so now and of course the in order to understand the meaning of the cumulative frequency, we can of course talk about it a little bit, meaning that here we said that n is equal to 100, which is an even number. So the median, as we said, that it's going to be the average of n divided by 2th observation and n divided by 2 plus 1th observation, right? The average of these two, which is basically to say 50th and 51st observation. Now, in order to find these observations, we need to basically, we can basically do it like this. So I can create a table over here, and I can write basically over here, I can write the marks obtained, and the number of students. Okay, and this is important to understand the concept of cumulative frequency. Now I know that the mark 20, the marks 20 has been obtained by 6 students, and I can say that up to the marks 25, has been obtained by how many students? So of course then you have to basically all the marks up to 25 would include basically these marks as well. So that would be 6 plus 20, which is 26. Again, you can say up to the marks 28 has been achieved by basically this number of students, which is 6 plus 20 plus 24, which is equal to 50. And in the same way, you can write up to, for example, 29, up to 33, up to 38, up to 42, and up to 43. And then you can write all of these numbers here, which we have already calculated. So 78, for example, 93, 97, 99, and 100. And so now we can add basically we can basically add this table to this table and call it cumulative frequency. Which is basically, if I add basically these two columns to my table, this becomes a cumulative frequency, which is basically, whose meaning basically is basically simply this. So I simply add basically this table to my table, and that becomes the cumulative frequency column basically. So that's basically what the concept of cumulative frequency actually means. Now what I can do, now from this table, I can see that the 50th observation is 28, because basically we said that up to basically about these marks, about specifically about this mark, we said that up to 28, the number of students who had gotten those marks were 50 students. So that means that there have been 50 students who have gotten marks, all the marks up to 28. So that means that 28 has been basically achieved by those 50 students. So that means that the 50th observation has been, of course, 28. So has been 28, and then we said that up to over here you can say that again, up to 29 has been achieved by 78 students, and that means that then, of course, the number 51 of course doesn't fall into this category anymore, because this goes all the way up to 50 and this goes all the way up to 78. So 51, you have to be looking for it in this category, which is the marks is 29. So you have to write 29 here, and here you have to write basically 28, right? So that's how you get your numbers. And so if you get the median of, and so then your median, so you got your marks now, and now your median is going to be equal to 28 plus 29 divided by 2, which is equal to 28.5. Which is equal to 28.5. So now, as a remark, the part of this table consisting column 1 and 3 is known as the cumulative frequency table, meaning that if you write basically your marks and this column over here, that would be called a cumulative frequency table. Okay, and the median marks 28.5. The median marks 28.5, which is basically the marks that comes exactly in the middle of all the observations, conveys the information that about 50% the students obtained marks less than 28.5, and another 50% students obtained marks more than 28.5. And so now let's see how to obtain the median of group data through the following situation. So this was of course not group data, and we don't have those class intervals and all of that business over here. Now let's see how to obtain the median of group data. Let's see how to find the median of group data. We have a situation over here. We'll go through this situation. So now what we have here is a grouped frequency distribution of some marks obtained. We have a grouped frequency distribution of marks obtained out of 100 by 53 students. By 53 students in a certain examination. Okay, so that's the situation that we have. So let's see what the marks look like. Okay, so now the data that we have is actually some table like this. So you have your marks here. You have your marks and the number of students. The number of students. So 0 to 10, we have 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. And the frequencies are 5, 3, 4, 3, 3, 5, 3, 4, 3, and 3. Let me separate these. Five, 3, 4, 3, 3, 4, 7, 9, 7, 8. 4, 7, 9, 7, 8. Okay, so that's the data that we have, and we want to find the median of this data. So of course, what we can do is basically the problem is that the number of students, if you add these together, you will get I think a 53. I think this the sum of all of this would be 53. So if that's the case, then you would get 53 is an odd number, so you would get n plus 1 divided by 2. So 54 divided by 2 is equal to 25, 27. The 27th observation. And the 27th observation would be, you have to add these numbers together. Again, you get the problem of finding the cumulative frequency of these numbers. So let's see how they have solved this problem. So so from this table, let's try to answer these questions. So question number 1 is, how many students have scored marks less than 10? So how many students have scored marks less than 10? Less than 10. So from this table, you can see that all the marks going from 0 to 9, because 10 is not included here, the number of all of those people is 5 people. So that's basically 5 students. That's basically 5 students. And then the answer is 5, of course, right? Now, how many students have scored less than 20 marks? Marks less than 20. Less than 20 would be basically would be all of these two groups, right? These are less than 10 and this is less than 20, and so this would be also included in the answer. So that would be 8 students. So observe that the number of students who have scored less than 20 includes the number of students who have scored marks from 0 to 10, right? As well as the number of students who have scored marks from 10 to 20, right? So the total number of students with marks less than 20 is 5 plus 3, which is equal to 8. We say that the cumulative frequency of the class 10 to 20 is 8, because it's 5 plus 3 is equal to 8. We have talked about this before. So similarly, we can compute the cumulative frequency of the other classes. That is the number of students with marks less than 30, less than 40, less than 100, and we get a table like this. We get a table over here like this, meaning that I would get a table like this, meaning that I could basically create a table over here. I said, okay, I can say marks and basically the number of students, and then over here you can write, for example, less than 10, less than 20, less than 30, less than 40, and so on and so forth. 40, 50, 60, 70, 80, 90, and 100. And 100. So then again, you need to just find the cumulative frequencies of these classes, meaning that you get 5 over here. 5 plus 3 is equal to 8. Then 8 plus 4 is equal to 12. 12 plus 3 is equal to 15. 15 plus 3 is equal to 18. 18 plus 4 is equal to 22. 22 plus 7 is equal to 29. 29 plus 9 is equal to 38. 38 plus 7 is equal to 45. And 45 plus 8 is equal to 53. Is equal to 53. So now the distribution given above is called the cumulative frequency distribution of the less than type. This is called the cumulative distribution, frequency distribution of the less than type, right? So here 10, 20, 30, 40, all the way up to 100 are the upper limits of the respective class intervals. So basically what that means is that in the cumulative frequency distribution of the less than type, you always have the upper class limits of all of the classes. There is also something called the cumulative frequency distribution of the something like the greater than type or something like that, in which case you always, instead of these numbers, you always have the lower limit of all of your class intervals. So that is that. So we can similarly make a table for the number of students with scores more than or equal to 0, more than or equal to 10. So you can write, for example, over here we can create another table. I can write over here marks and the number of students, and then over here I can write basically scores more than 0, for example, more than 10, more than 20, more than 30, 40, 50, 60, 70, 80, 90, and that's it. So 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. And so you can see that basically the way that you can calculate the number of students here is that basically the number of students who have gotten basically marks more than 100 is basically, I'm sorry, more than 0 is basically all of these students. More than 0 would be all of these students. That means that it's basically 53. And then you have more than 10 would be basically these students less than, I mean, all of the students minus 5. So that would be 53 minus 5, which is equal to, for example, 48. Then again, more than 20 would be all of the students except for these two groups, meaning that basically 53 minus 5 minus, for example, 3, which is 53 minus 8, which is equal to 45, for example. And in the same way, you can basically keep calculating. For example, more than 30 would be all of the students except for these students, and these students are 5 plus 3 plus 9 is equal to 12. So then 53 minus 12 is equal to, for example, 41. So that is 41, and so on and so forth. So now let's see what we have over here. So we observe that all the 53 students have scored marks more than or equal to 0. So this is of course supposed to be more than or equal to. More than or equal to. Since there are 5 students over here scoring marks in the interval 0 to 10, this means that there are 53 minus 5 students getting more than or equal to 10 marks. So since there are 5 students scoring marks in the interval 0 to 10, this means that there are 53 minus 5 students, which is 48 students, getting more than or equal to 10 marks. And continuing in the same manner, we get the number of students scoring 20 or above, as for example 48 minus 3. So you always have to basically get this number and then basically subtract basically these numbers from this number minus this number minus the next number minus the next number, and so on and so forth. And these are shown in this table over here. So then you can say that you can say over here the marks. So let me now rewrite this table over here. So if I were to rewrite this table, I would write it as, first this is this table, let's not mix things up. And then over here I can do this thing over here. And then basically one column becomes basically the marks obtained. And another column becomes the number of students, or becomes the number of students, or cumulative frequency. Okay. And so then you can come up with these basically with these categories as, for example, more than or equal to, for example 0, more than or equal to 0, and then you have more than or equal to, for example, 10, 20, 30, 40, 50, 60, 70, 80, and 90. So what that means is that basically then more than or equal to 0 would be all of these students whose number is we have calculated to be 53. So that is 53. And then basically the next one more than or equal to 10 is 53 minus 5 is 53 minus 5, which is equal to basically 48. And then the next one more than or equal to 20 would be basically 48 minus basically 48 minus then as long as you're working with these numbers, then you don't have to keep track of these numbers anymore, meaning that you can write over here 48 minus, for example, this number 3, which is equal to 45. Then the next one you can write 45 minus 4, for example, which is equal to 41. Then you can write 41 minus 3, which is equal to 38. Then you can write 38 minus again 3, which is equal to 35. Then you can write 35 minus 4, which is equal to 31. Then you can write 31 minus 7, which is equal to 30, and 6, so 24. Then you can write 24 minus, for example, 9. 24 minus 9, which is equal to 14, 15. And then you have 15 minus 7 minus 7, which is equal to 8. So you will end up with the same number over here. Okay. So that's basically that. So that this table over here is the cumulative frequency distribution of the more than type. So this table over here is called the cumulative distribution, frequency distribution of the more than type. And this table over here is called the cumulative frequency distribution table. Cumulative frequency distribution table of the less than type. Okay, so that is basically this table over here. And here basically these numbers 0, 10, 20, 30, and so on and so forth give the lower limits of the respective class intervals. Now, to find the median of the group data, we can make use of any of these cumulative frequency distributions, either this one or this one. And let's combine these tables together to get to this table, meaning that we get our marks over here, and then the number of students over here, we call this F, for example. And then the cumulative frequency C of F, we will use the less than type. The less than type is much more. You end up using this much more often than you use this one. In certain situations, of course, you will need this one as well, but this one is much more general purpose. So then I can erase this over here. I can erase this over here, and then I can basically add a let me create this thing over here, and then so I call this is the number of students, and over here you have the cumulative frequency, or CF, cumulative frequency, right? So now the cumulative frequency of basically of these students is basically, for example, what this number, for example 5, represents here is the number of the students who have scored less than 10, less than 20, less than 30, less than, and so on and so forth. So you get 5, 8, for example, 12, 15, and 18, and 22, and 29, and 38, and 45, and 53. That is the total number of the students. And so now we can erase all of these. Right, we can erase this one and also this one. And now we have this table that that basically contains our marks, the number of the students, or the frequency, and the cumulative frequency. Now in a group data, we may not be able to find the middle observation by looking at the cumulative frequencies, as the middle observation will be some value in a class interval. It's therefore necessary to find the value inside a class that divides the whole distribution into two halves. But which class should this be? So now, as you can see, our observations have been buried inside these classes, and the only thing that we have about these classes is that, for example, I know that there have been 3 observations whose values have been between 40 and 50, and to be more exact, between 40 and, for example, 49. And there have been, for example, 7 observations whose values have been between 60 and 69, and so on and so forth. But I don't really know basically what sort of observations have exactly gone into these classes. I just know the number of them. So now now the question that we want to answer is that it's therefore necessary to find a value inside the class that divides the whole distribution into two halves. Divides the whole distribution into two halves, but which class should this be? Meaning that you want to basically find a class, and then in that class find some x of I that basically divides the whole distribution into two equal halves. Now, in order to do that, first of all, you need to find the class. So now, in order to find this class, we need to find the cumulative frequencies of all the classes and n divided by 2. The cumulative frequencies of all the classes and n divided by 2. And then we locate the class whose cumulative frequency is greater than or nearest to n divided by 2. So n divided by 2 is basically, let's assume that n is equal to 53. And so based on that, n divided by 2 is equal to 25, 26.5. 26.5. So now you need to locate the class whose cumulative frequency is greater than or nearest to n divided by 2. So basically what that means is that your if you were looking for now if we actually were doing this manually, what would we do? So this is basically the data that I have. These are the respective basically frequencies of these classes, and these are the cumulative frequencies of those classes. So I know that my n is 53, right? My n is 53. And so we said that basically the median of the data, if the let me see, I forgot that. See, if you have, for example, 1, 2, 3, 4, and 5 observations here, so it's easy, this will be your median. If you have 6 observations, then you get 2 medians, and you need to find the average of those 2. So then in that case, you would get, for example, n divided by 2 observation and n divided by 2 plus 1th observation, right? So what that means is that n divided by 2th observation and n divided by 1th observation, in this case we have to go with this because the number here is odd, right? So now n divided by 2th observation is no, this is for the case when we have an even number of observations. This is for even. When the number is odd, you can simply go for n plus 1 divided by 2. N divided by 1 divided by 2, n plus 1 divided by 2. So in this case, for example, you would have to find the n plus 53 plus 53 plus 1 divided by 2, which is equal to 54 divided by 2. 54 divided by 2, which is equal to 25 and 27. So 27th observation. Now 27th observation would be of course greater than 26.5, right? So that's basically why we said that basically we have to find n divided by 2, and then we have to go for the cumulative frequency, which is greater than n divided by 2. So then you just simply keep looking for the 27th observation, or basically in these numbers in the cumulative frequency. So basically what that means is that of course it cannot be 22, but it's definitely in this class interval, because here your observations go all the way up to 29. So 27 is somewhere over here. So now that I know that my observation is somewhere in this class, I have some idea what that observation might have been, meaning that I know that the observation has been either 60 or 61 or 62 or 63 or 64 or 65 or 66 or 67 or 68 or 69. Now, I don't know what they do here. Maybe they take the average of that or something like that. Of course, naturally you have to take the average of that, because, or no, not the average, but the not the mean, but the median of that number. The median of that number, the number that comes exactly probably over here. Let's see what they do. So then we said that we now locate the class whose cumulative frequency is greater than or nearest to n divided by 2. So if it's supposed to be greater than n divided by 2, it's supposed to be this one, and this is called the median class. This is called the median class. And in the distribution above, n is equal to 53. So n divided by 2 is equal to 26.5. Now 60 to 70 is the class whose cumulative frequency is 29. 29 here is greater than or nearest to n divided by 2. That is 26.5. Therefore 60 to 70 is the median class. Okay. Now after finding the median class, we use the following formula for calculating the median. So now we need to use a formula. So we need to erase all of these. We don't need them anymore. Okay, so we need to use a formula which is basically the median is equal to L plus n divided by 2 minus CF L plus n divided by 2 minus CF divided by F times H. So that means that you take the lower limit of probably the class of the median class, and then n divided by 2 is basically this number here, 26.5, which is basically half of n. CF is the cumulative frequency of the class preceding the median class. So CF is the cumulative frequency of the class preceding the median class, meaning that the cumulative frequency of this cumulative frequency, so that means that you take n divided by 2, which is 26.5, and subtract from that this cumulative frequency, which gives you and then you divide the whole thing by F, which is basically the frequency of the median class, and then you multiply the whole thing by the class size. So let me see. Okay, so what this formula is doing for us here is actually, it's not that complicated. So when you find your median class, which is basically this class over here, then there is an L, which is the lower limit of that class. And so then you have basically the lower limit of that class plus n divided by 2, which is this value over here. This is the number of all of the observations. So the number of all of the observations divided by 2, you get 26.5. 26.5 minus C of F minus CF, the cumulative frequency of this class interval prior to the median class, which is 22. And divided by the frequency of the median class, which is 7. So that gives you over here some value like 0.64. This value over here would be something like 0.64. And when you multiply it by the class size, which is 10 here, this times 10 is going to give you 6.4. So this is going to be 66.4, which here they have taken it as 66.4 exactly. So that's basically how this formula works. So now what this means is that about half the students have scored marks less than 66.4, and the other half have scored marks more than 66.4, and that's basically your median. Okay, so that's basically how you find the median of some data. Let's do another example, or probably a few more examples here, because I think we need to spend some more time with the median. And so basically that we will do in the next video. I'll see you in the next video.